The alarm sounds at 2:47 a.m. on a freezing November night in 1978. Inside the cavernous darkness of the Monongahela Valley Ironworks, the beast is waking. Blast Furnace Number 7 stands 17 stories tall, a cathedral of brick and steel that has turned iron ore into molten metal for 43 years. Tonight, it becomes a tomb. The night crew, 173 men working the graveyard shift, moves through their routines in the shadow of the furnace. They check temperatures. They monitor gas pressures. They prepare for the next cast. The heat radiates from the furnace stack, like a physical presence, turning the November cold into sweltering warmth within 50 feet of the structure. At 3:12 a.m., the gas pressure gauge in the control room begins to fluctuate, a warning that goes unheeded. At 3:19 a.m., a maintenance worker notices an unusual smell near the furnace base. He mentions it to his supervisor, who tells him to keep working. At 3:23 a.m., the backdraft occurs. The explosion is not loud at first. It is a deep, subsonic thump that men feel in their chests before they hear it. Then comes the fireball. A column of superheated gas and flame erupts from every opening in the furnace structure, driven by a sudden reversal of pressure that turns the entire 17-story monster into a vertical flamethrower. Men 50 yards away are engulfed instantly. The blast wave knocks workers off platforms. The heat flash ignites clothing, melts safety equipment, turns the air itself into poison. In 4 seconds, the primary explosion kills 97 men. In the next 6 minutes, as toxic gas floods the lower levels and burning debris traps crews in the casting pit, another 76 will die. To understand how 173 men die in a single industrial accident requires understanding how America built its steel empire on calculated risk and acceptable casualties. The blast furnace is not an invention of the industrial age, but a refinement of ancient technology. Chinese ironmasters were using similar principles in the 5th century BC, but American capitalism scaled it to monstrous proportions. By the 1970s, integrated steel mills stretched for miles along rivers in Pennsylvania, Ohio, Indiana, and Illinois. These were not factories, but entire industrial ecosystems. A single facility employed 10,000 workers. Blast furnaces like Number 7 at Monongahela Valley Ironworks operated continuously for years, sometimes decades, without shutting down. The economic logic was simple. Stopping meant losing production, and production was everything. The Monongahela Valley Ironworks opened in 1923, built by a consortium of Pittsburgh financiers who understood that steel was power and power was profit. By 1978, the facility is aging. Competition from overseas producers intensifies. Management defers maintenance. Inspection schedules slip. The company hires efficiency consultants who recommend reducing crew sizes and extending operating cycles. The night shift, once staffed with 200 men, now runs with 173. The union protests. Management responds with layoff threats. Men who have worked at the mill for 20 years accept the new conditions because there are no other options in a valley where steel is the only industry that pays a living wage. This is the context in which disaster incubates. The blast furnace operates on a principle that would terrify anyone who truly understood it. Iron ore, coke, and limestone are loaded into the top of a towering shaft. Superheated air, sometimes reaching 2,200 degrees Fahrenheit, is blasted into the bottom. The oxygen in the air reacts with the carbon in the coke to produce carbon monoxide, a reducing agent that strips oxygen from iron ore, leaving molten iron that collects at the furnace base. This molten iron, at temperatures exceeding 2,800 degrees Fahrenheit, is periodically tapped and poured into ladles for transport to steel-making furnaces. The entire system depends on precise control of temperatures, gas pressures, and airflow. Blast Furnace Number 7 at Monongahela Valley Iron Works is what workers call a beast. It is one of the largest in the region, capable of producing 2,400 tons of iron per day. It has been in continuous operation since 1935, relined twice, modified dozens of times, patched and repaired so many times that maintenance records fill an entire filing room. The furnace generates enormous volumes of blast furnace gas, a mixture of carbon monoxide, carbon dioxide, nitrogen, and hydrogen. This gas is captured, cleaned, and used as fuel throughout the mill. But the system for managing this gas is complex, prone to leaks, and dependent on ventilation fans that must operate continuously. If the fans fail, if pressure differentials shift, if any part of the delicate balance breaks down, the gas becomes a lethal atmosphere that can asphyxiate workers in seconds or, under the right conditions, explode with devastating force. The danger the men of Monongahela Valley Iron Works cannot see is often deadlier than the dangers they can. Carbon monoxide is odorless, colorless, tasteless. At concentrations above 1,000 parts per million, it causes unconsciousness in minutes and death shortly after. The blast furnace generates it continuously. Hydrogen, also present in blast furnace gas, is explosively flammable in concentrations as low as 4% in air. The casting floor, where crews work during tapping operations, is routinely filled with gas concentrations that would alarm any industrial hygienist. But the men have grown accustomed to the smell, the faint, acrid odor that signals gas buildup. They know when to move upwind, when to avoid certain areas, when to hold their breath. This accumulated knowledge keeps them alive usually. Management knows about the gas hazards. Internal memos from 1974 document concerns raised by the company's safety director about inadequate ventilation in the casting area. The memos recommend installing additional exhaust fans and gas monitors. The recommendations are shelved due to budget constraints. In 1976, a worker dies from carbon monoxide exposure after a ventilation fan fails. The incident is ruled an accident. OSHA inspects, issues citations, and the company pays a fine of $3,200. New gas monitors are installed but never properly calibrated. Workers learn not to trust the alarm systems, which false alarm so frequently that supervisors routinely disable them to maintain production. This is the environment in which 173 men report for their shift on November 3, 1978. The pattern of failures at Monongahela Valley Iron Works does not begin in 1978. It stretches back decades, an accumulation of small compromises that collectively create catastrophic vulnerability. In 1958, a gas explosion in the same furnace area injures 12 workers. The investigation identifies inadequate ventilation and recommends system upgrades. The upgrades are partially implemented. In 1963, a casting accident spills molten iron across the floor, killing 2 men and severely burning 5 others. The investigation cites insufficient safety barriers and inadequate emergency response protocols. New barriers are installed but prove inadequate during subsequent incidents. In 1969, a furnace water jacket failure floods the lower casting pit, creating a steam explosion that injures 8 workers. The investigation identifies corroded piping and deferred maintenance. Management promises improvements. In 1972, carbon monoxide poisoning sends 17 workers to the hospital when ventilation fans fail during a production peak. The local newspaper runs a story. The union calls for federal intervention. OSHA conducts an inspection and issues citations. The company pays fines totaling $18,000. In 1975, a small backdraft explosion, a preview of the catastrophe to come, blows out windows in the control room and burns 3 workers. The incident is not reported to federal authorities. The company classifies it as a minor safety incident and settles workers' compensation claims quietly. Each of these incidents is investigated, analyzed, and filed away. Each generates recommendations that are partially implemented or ignored entirely. Each offers an opportunity to prevent the disaster that is coming. But the economic pressures are relentless, and safety improvements that do not directly increase production are always the first items cut from budgets. The men who work at Monongahela Valley Iron Works are not ignorant of the dangers. They know the furnace is old, that ventilation is inadequate, that gas monitors are unreliable. They know because they breathe the air and feel the heat and see the patched equipment and jury-rigged repairs. But they also know that Monongahela Valley is a company town, that the ironworks is the largest employer for 50 miles, that jobs paying $18 an hour with full benefits and pensions do not exist anywhere else in a region where unemployment hovers near 12%. For many of the men on the night shift, working at the mill is a family tradition. Fathers train sons in the rhythms of the furnace, in the subtle signals that indicate problems, in the informal knowledge that keeps workers alive in an environment that is inherently lethal. This knowledge is valuable, but it is also a trap. It creates a false sense of mastery over systems that are fundamentally unpredictable. The men take pride in their skill and their toughness. They mock safety inspectors who visit from headquarters wearing clean hard hats and clip-on ties. They tell stories about close calls with a mixture of bravado and dark humor. This culture of resilience is also a culture of denial. To acknowledge the full extent of the danger would be to acknowledge that they are risking their lives for a company that values production over their survival. So they show up, shift after shift, and trust in their experience and their luck. The sequence of events that leads to the disaster begins not at 3:23 a.m. when the backdraft occurs, but at 10:47 p.m. the previous evening, when the day shift supervisor notices unusual pressure readings in the gas offtake system. The readings suggest a partial blockage somewhere in the gas cleaning system, a problem that should prompt an immediate investigation and possibly a controlled furnace shutdown. But shutdowns are expensive. Every hour of lost production costs the company $65,000, and the shift supervisor is under intense pressure to meet production quotas. He makes a decision that will haunt his nightmares for the rest of his life. He decides to monitor the situation and allow the night crew to handle it if it worsens. At 11:30 p.m., the night crew begins their shift. The shift supervisor is briefed on the pressure readings, but not given any specific instructions. He assigns a maintenance team to investigate. They check accessible sections of the gas system and find nothing obviously wrong. The pressure readings continue to fluctuate. At 1:15 a.m., a ventilation fan in the casting area begins to run intermittently, a mechanical problem that reduces airflow by approximately 30%. The reduction is noticeable. Workers mention that the air feels heavier, that the gas smell is stronger. But the fan is old and temperamental, and intermittent operation is not unusual. No one calls for repairs. At 2:47 a.m. the alarm sounds. Not a gas alarm or an emergency alarm, but the routine signal that the furnace is ready for the next tap, the process of draining molten iron from the base. The tapping crew assembles in the casting area. 23 men, including the crew chief, the tap hole driller, the mud gun operators, and the ladle crane operator. They are positioned around the furnace base, preparing to drill open the tap hole and channel molten iron into the waiting ladle. At 3:12 a.m., the partial blockage in the gas system suddenly clears. The immediate result is a surge of blast furnace gas through the system, a pressure wave that overwhelms the ventilation capacity. Gas floods into the casting area where the tapping crew is working. The malfunctioning ventilation fan cannot clear it. The gas is heavier than air and sinks into low-lying areas, filling the casting pit like invisible water. At 3:19 a.m., a maintenance worker smells the gas. He reports it. His supervisor tells him to stay clear of the area, but does not order an evacuation. The tapping operation is almost complete. At 3:23 a.m., a spark, possibly from the drilling operation, possibly from electrical equipment, possibly from molten metal contact, ignites the gas-rich atmosphere in the casting pit. The initial flash fire is not the disaster, it is what happens next. The combustion consumes oxygen and generates enormous heat, creating a sudden vacuum and pressure differential inside the lower furnace structure. This pressure differential reverses the normal airflow, sucking outside air into the furnace through every opening. The incoming air mixes with superheated gas and partially combusted materials inside the furnace, creating ideal conditions for a backdraft. The backdraft explosion is a violent exhalation. Every opening in the 17-story structure becomes a jet of flame. The blast doors on the tapping floor, designed to contain routine gas releases, are blown off their hinges. The tapping crew is directly in the path of the fireball. Men are incinerated where they stand. Others, engulfed in flame, run blindly and fall into the casting pit or over railings. The blast wave propagates through connected structures: the control room, the maintenance shop, the adjacent furnace areas. Windows shatter, steel beams warp, concrete cracks. Men are thrown from platforms, crushed by falling debris, trapped under collapsed structures. And then the gas comes. With ventilation systems damaged and pressure differentials chaotic, carbon monoxide floods the lower levels of the facility. Men who survived the initial blast stumble into this invisible poison and collapse. Rescue workers arriving from other areas of the mill are overcome before they realize the danger. The disaster unfolds in layers, each wave of destruction claiming more victims. The destruction does not end with the initial explosion. The blast damages gas lines throughout the facility, creating multiple leak points that feed secondary fires. Molten iron from the interrupted tapping operation flows across the damaged floor, igniting anything combustible and creating additional hazards for rescue attempts. The furnace itself, its internal structure damaged, begins to deteriorate. At 4:07 a.m., a section of the furnace wall fails, releasing a cascade of semi-molten material onto the area below. This secondary collapse crushes the remains of the casting shed and generates another wave of toxic gas. The expanding destruction transforms the disaster from a localized incident into a facility-wide catastrophe. Workers in adjacent areas, initially unaware of the severity of the situation, are caught in the spreading gas cloud or trapped by spreading fires. The electrical system, damaged by the blast, fails in sections, plunging parts of the facility into darkness. Emergency lighting systems prove inadequate. Rescue efforts become chaotic as responders struggle to navigate smoke-filled, darkened structures while avoiding gas pockets and unstable wreckage. The mill's fire brigade, trained for routine industrial fires, is overwhelmed. Mutual aid is requested from surrounding communities, but the scale of the disaster and the specialized hazards of the steel mill environment delay effective response. By dawn, portions of the facility are still burning, gas leaks continue, and the full extent of the casualties is not yet known. What is known is that Monongahela Valley Iron Works, one of the region's largest employers and a symbol of American industrial might, has become a mass casualty site. The final count takes 3 days to compile. 173 men dead, 42 injured, 23 of them critically. The dead include nearly the entire night shift tapping crew, most of the maintenance staff working in the lower furnace areas, and multiple rescue workers who died attempting to save their colleagues. The bodies are recovered slowly, on some from areas so damaged and contaminated that recovery workers must wear full protective equipment and work in short shifts. Some victims are identified only through dental records or personal effects. The morgue in the small valley town is overwhelmed, and a temporary facility is established in the high school gymnasium. The community is devastated. In a town of 8,400 people, nearly every family has lost someone or knows someone who has lost someone. The funerals stretch over 2 weeks. The churches are full. The newspaper runs page after page of obituaries. The high school cancels classes for a week. The psychological trauma extends beyond the immediate families. Survivors struggle with guilt, nightmares, survivors' trauma. The local mental health system, minimal even before the disaster, is completely inadequate to address the need. The disaster is a wound that will never fully heal. The investigations begin immediately and will continue for years. The Federal Mine Safety and Health Administration, OSHA, the Chemical Safety Board, the Pennsylvania Department of Labor and Industry, all launch inquiries. The company hires its own investigation team. The union demands an independent investigation. The findings, when they finally emerge, are damning, but also frustratingly inconclusive. The immediate cause, the gas ignition and subsequent backdraft, is clear. The contributing factors are numerous: inadequate ventilation, malfunctioning safety equipment, deferred maintenance, insufficient gas monitoring, inadequate emergency procedures, insufficient training, production pressure overriding safety concerns. The investigators identify 17 separate safety violations, 8 of which individually could have contributed to the disaster. Responsibility is harder to assign. Company executives claim they were unaware of the extent of the safety problems, that supervisors failed to escalate concerns, that workers themselves sometimes disabled safety equipment. Supervisors claim they were under impossible production pressure, that requests for maintenance and equipment were routinely denied, that they flagged problems that were ignored. Workers, both survivors and the families of the dead, claim the company prioritized profit over safety, that warnings were ignored, that the disaster was preventable and predicted. The legal proceedings drag on for years. Eventually, the company settles wrongful death claims for an undisclosed sum. No criminal charges are filed. The CEO issues a statement expressing deep regret for this tragic accident, but accepts no personal responsibility. OSHA issues the largest fine in its history to that date, $1.8 million, later reduced to $740,000 on appeal. The company, facing bankruptcy due to the combined costs of the disaster, legal settlements, facility repairs, and declining steel markets, closes the Monongahela Valley facility permanently in 1981. The blast furnace is dismantled, the structures are demolished, the site becomes an industrial brownfield. The fundamental reason the disaster happens, and why similar disasters continue to happen, is a conflict between economic logic and human safety that is baked into industrial capitalism. Operating a blast furnace safely requires constant investment in maintenance, equipment upgrades, training, and sufficient staffing. These investments reduce profit margins. In a competitive market, especially when facing overseas competition with lower labor costs, companies face constant pressure to cut costs. Safety improvements that do not directly increase productivity are always vulnerable to budget cuts, especially when the consequences of those cuts are uncertain and distant. The men who run these companies are not monsters. They are responding to the incentives of a system that rewards short-term profit maximization and punishes investment in long-term safety. The regulatory system is supposed to counterbalance these incentives, but regulators are chronically understaffed, underfunded, and face political pressure not to burden industry with excessive regulations. Inspections are infrequent. Violations, when found, result in fines that are small relative to company revenues. Enforcement is slow. The result is a regime where companies conduct their own cost-benefit analysis, weighing the cost of safety improvements against the probability and cost of an accident. Sometimes they guess wrong, and people die. What changes after a disaster like Monongahela Valley? New regulations are written. Existing regulations are more strictly enforced, at least temporarily. Companies invest in safety improvements, at least for a while, but memory fades. Economic pressures remain constant. New executives arrive who did not live through the disaster and see safety systems as cost centers to be optimized. The cycle continues. The question is not whether there will be another disaster, but when and where and how many will die before the economic logic changes. The physical remnants of the Monongahela Valley Ironworks are gone, scraped away and sold for scrap. But the disaster leaves a legacy that endures. It changes the way steel companies approach furnace safety, at least temporarily. New ventilation standards are written. Gas monitoring systems become mandatory. Backdraft prevention becomes a standard element of furnace design. The disaster contributes to a broader shift in American industrial culture, away from the assumption that workplace danger is simply part of the job and toward the idea that workers have a right to safe working conditions. The families of the victims fight for this legacy. They form an advocacy organization that pushes for stronger safety regulations, better enforcement, and criminal penalties for executives whose negligence leads to worker deaths. The organization still exists, though its membership has dwindled. The town itself never fully recovers. The loss of the mill, which follows the disaster by only 3 years, removes the economic foundation of the community. Population declines. Young people leave for opportunities elsewhere. The buildings decay. By 2025, the town has fewer than 3,000 residents, and the median age is over 50, but memory persists. A memorial stands near the site of the former ironworks, a black granite wall engraved with 173 names. Every year on November 3rd, the survivors and families gather for a remembrance ceremony. The crowd gets smaller each year. The survivors are aging. The children who lost fathers are themselves now grandparents. But they come, because remembering is the only thing left. The lesson of the Monongahela Valley Ironworks blast furnace disaster is not complicated. People died because profit was prioritized over safety, because warnings were ignored, because the immediate cost of prevention seemed too high compared to the distant possibility of disaster. It is a lesson written in blood at industrial sites across the nation and around the world. It is a lesson that is learned and forgotten and learned again, each time at terrible cost. The 173 names on that memorial are not statistics. They are fathers and sons, brothers and husbands, men who went to work on a cold November night and never came home. Their deaths demand more than remembrance. They demand that we build systems that ensure such preventable disasters do not happen again. Whether we have the collective will to do so remains an open question,